Hi everyone, welcome to another session of the HBL files. In today's session, we will be solving problems about the other forms of direct proportion. Let's begin. For the first problem, if z squared is directly proportional to x cubed and z is equal to 8 when x is equal to 4, find the values of z when x is equal to 9. Let's begin the solution by transforming this phrase into a mathematical statement. Notice that it was mentioned that z squared is, so equals, directly proportional, that means k times x cubed. Then, let's solve for k using the initial conditions given. Let's substitute 8 for z and then 4 for x, giving us 8 squared over 4 cubed. 8 squared is equal to 64, while 4 cubed is 4 times 4, which is 16. 16 times 4 is also 64, giving us a final k value of 1. We then substitute this k value of 1 to this general equation that we have started with, giving us z squared is equal to x cubed. Then, let's substitute the second value of x to find the possible values of z. Let's substitute 9 to x, giving us z squared is equal to 9 cubed. Now, if you don't want to deal with very large numbers, we can express 9 in terms of its prime factors. 9 is equal to 3 times 3, or simply 3 squared. Simplifying this, we just multiply the powers, giving us z squared is equal to 3 raised to 6. We then get the square root of each side of the equation. The square root of z squared will of course be z, and then the square root of 3 raised to 6 will be positive or negative 3 raised to 3, or simply positive or negative 27. This means that the z value can either be positive 27 or negative 27. Now, why is this the case? Notice that in the equation for this scenario, z was squared. Notice that if you square positive 27, the result will be a positive number. And then on the other hand, if you square negative 27, notice that the numbers are the same except for the signs, of course. If you square negative 27, the result will of course be a positive number as well. So for this question, the answer will be z can be positive 27 or z can be negative 27. Next. For this question, if q is directly proportional to the square of p minus 1 and q is equal to 20 when p is equal to 3, find the values of p when q is equal to 80. As usual, let's start the solution by writing down first the general equation for this scenario. It was mentioned that q is directly proportional. That means q equals k multiplied by or multiplied to the square of p minus 1. Solving for k, we have q over the square of p minus 1. We can solve k by substituting the initial values for p and q. q is 20, p is 3. This reduces to 20 over 2 squared, or 20 over 4, giving us a final value of k to be equal to 5. We then substitute this value of k to this general equation, giving us q is equal to 5 times the square of p minus 1. Let's now find the value of or values of P when Q is equal to 80. Substituting 80 to Q, we have this. Let's divide each side of the equation by 5, giving us 16 on the left side of the equation. To remove this square here, we get the square root of each side. Then square root of 16 can either be positive or negative 4. The square root of the square of P minus 1 is, of course, P minus 1. Now, here, what does this mean? It means that P minus 1 can be equal to positive 4, or P minus 1 can be equal to negative 4. So we have to solve it part by part, like this. For this equation over here, we transpose negative 1 to the other side, giving us 4 plus 1 is equal to P. We do the same thing for this second equation. Negative 1 transposed to the other side, that becomes positive 1. 4 plus 1 is 5. Negative 4 plus 1 is negative 3. That means the two values of P when Q is equal to 80 will be 5 or negative 3. Now, if you're not sure of the answers that you have arrived with, you can always do some checking, like this. Here, let's first check if 5 will, as a value of P, will really give us a value of 80 for Q. So let's use the equation. Q is equal to 5 times the square of P minus 1. Let's substitute this value to P, giving us this one. 5 minus 1 is 4. 4 squared is 16. 5 times 16 is 80. That means this value is correct. Let's try when P is equal to negative 3. Again, we use this equation. Substitute negative 3 to P. Negative 3 minus 1 is negative 4. Negative 4 squared is positive 16. 16 times 5 is 80. That means that the values we obtained for P are correct. Next question. Given that y is directly proportional to x cubed, copy and complete the table. We'll begin the solution by the general equation. Y is equal to kx cubed. Again, we used this part of the problem as the guide. Y equals directly proportional k times x cubed. We then solve for k by using or by manipulating the equation and arriving at y divided by x cubed. Now, notice that on the fourth column or in this column, we have an x and y values. We can use this to substitute the values here. Y is 648 while x is 6. And then we cube 6. 6 cubed is equal to 216. And 648 divided by 216 is equal to 3. Substituting this value of k to the general equation, now have y is equal to 3x cubed. We then use this equation to solve for the missing y values and x values. For the first one, when x is equal to 3, we substitute 3 to x. We now have 3 cubed. 3 cubed is 27. 27 multiplied by 3 is 81. When x is equal to 3, y is equal to 81. Next, when x is equal to 4, again, we use the equation for this scenario. We substitute 4 to x. 4 cubed is 64. 64 multiplied by 3 is 192. On the next part, we are asked to solve for x given the y value. So here, we use the equation again, substitute 375 to y, and let's divide each side of the equation by 3, giving us 375 over 3, or 125. We then get the cube root of each side. Now, if you're having difficulty getting the cube root of a number, you can express this number in terms of its prime factors. Now, for 125, the prime factors will be 5 times 5 times 5. Of course, the cube root of x cubed will be x. Here, we can see that the cube root of 125 will be 5. That means when y is equal to 375, x is equal to 5. And lastly, for this item, you have a y value of 1029. Substitute this value to y, we have this equation. Let's divide each side of the equation by 3, giving us a value of 343 for the left side. And then, same procedure, get the cube root of each side. Now, expressing 343 in terms of its prime factors, that's going to be 7 times 7 times 7, giving us a final value for x to be equal to 7. So when y is equal to 1029, x is equal to 7. Next problem. During a certain period in the life of an earthworm, its length L centimeters is directly proportional to the square root of n, where n is the number of hours after its birth. 1 hour after an earthworm is born, its length is 2.5 centimeters. Okay, let's go through each question one by one. For the first one, find an equation connecting L and N. Again, we begin with the transformation or translating the statement into an equation. It says here that L is directly proportional to the square root of N. So L equals directly proportional, so K times square root of N. We then rearrange the equation to solve for K, and we will solve for K using the initial values given. 1 R for N, 2.5 centimeters for L. That gives us 2.5 over square root of 1, and square root of 1 is simply 1, giving us a final value of K to be equal to 2.5. That means our equation for this scenario, for this problem, will be L is equal to 2.5 times the square root of N. Now, to answer the second question, find the length of an earthworm 4 hours after its birth. We use the equation we obtained for the first question. We substitute 4 to N. Remember that N refers to the number of hours. So 4 replaces N. Square root of 4 is 2, and 2 times 2.5 will be 5 centimeters. Okay, so the length of the earthworm 4 hours after its birth is 5 centimeters. Since this is a problem wherein units are specified for each of the variables, then we should include also the unit in our answer. Next, for the third question, how long will it take for an earthworm to grow to a length of 15 centimeters? So again, we start with this equation. We are given with length this time, and we were asked to determine the number of hours. So we substitute 15 to L, and then we divide each side of the equation by 2.5. 15 divided by 2.5 is 6. We then get the square of each side of the equation, or we square each side of the equation. giving us the following. 6 squared is basically 36. That means n, or the number of hours, will be equal to 36 hours. So in order, or the time it takes for an earthworm to grow to a length of 15 centimeters will be 36 hours after its birth. Okay, for the last problem, if y is directly proportional to x squared and the difference in the values of y when x is equal to 1 and x is equal to 3 is 32, find the value of y when x is equal to -2. Okay, let's solve this problem part by part, beginning with the translation of this information into an equation. Y is, that means y equals directly proportional k times x squared. Now, notice that we were given with two initial values of x. X is equal to 1 and x is equal to 3. Now, to differentiate the two values, let's assign 1 to be our x sub 1 and 3 to be our x sub 2. So we have the following. When x is equal to 1, we make this general equation into this one with the proper subscripts. Since this is x sub 1, the corresponding value will also be y sub 1. Now, notice that I did not put a subscript for k. Because again, k is a constant. Since this is direct proportionality, meaning whatever the set of values for x and y, the k value will always be the same. So here, we substitute the value of 1 for x sub 1, giving us y sub 1 is equal to k. This is the initial equation that we can get out of the first condition of having x is equal to 1. Now, let's go to the second condition when x is equal to 3. Let's denote that as x sub 2 to differentiate the two values from one another. So since this is x sub 2, of course, the corresponding value of y should be y sub 2. We then substitute 3 to x sub 2, giving us y sub 2 is equal to 9k. Again, we did it like this because we're given with two conditions and nothing else so far. We don't know the k value, and to differentiate the corresponding y values for each x values, we have to use a specific subscript to know which one is which. Now, let's make use of the next information given to us, which is this part, the difference in the values of y, meaning y sub 2 minus y sub 1. It says here, difference in the values of y is 32. So y sub 2 minus y sub 1 equals 32. Now, why did I know, or how did I know that it's supposed to be y sub 2 minus y sub 1 and not y sub 1 minus y sub 2? Now, this is a direct proportionality, meaning as x squared values increase, y values should increase as well. Now, notice here, the x squared value is 9. In this scenario, the x squared value is 1. So you have an increase in the x squared value here. That means the corresponding y value should also be larger. So it should be y sub 2 minus y sub 1 equals 32. Now, we then substitute the expressions for y sub 2 and y sub 1 that we obtained in the two scenarios. Y sub 2 is replaced by 9k. Y sub 1 is replaced by k. Now, it's like k is acting like a variable. 9k minus k will be 8k, giving us 8k is equal to 32. Dividing each side of the equation by 8, this gives us a final value of k of 4, which means we can now substitute this value to k in this equation, giving us y is equal to 4x squared. This is the equation for this scenario. Now that we have this equation, we will now be able to solve the value of y when x is equal to -2. We simply substitute -2 to x. -2 squared is +4. 4 times 4 is 16. And that's it. That's how we solve these other forms of direct proportion. I hope everything's clear. And as always, thank you for learning with me today. See you in the next session of the HBL files.